Well, hi, good morning. Thanks so much for joining me in my shop here. It's April 20th. So yesterday went well, and then it didn't go so well at the end. Seems to me I found a defective capacitor, and I found a weird resistor, and I set all that nice and straight, and when I operated the radio, hey, it worked. FM worked fine. Worked very good, actually. Except one of the components I put in, the resistor, just sitting right here, got stupidly hot. 120 degrees C, according to my measurement. So how does it get to 120 degrees C? That's a good question. So I wondered, well, how much power is it supposed to be dissipating? I picked 10 milliamps as the current through it, as a bit of a guess. You'll see in a minute that's a good guess. And calculated that the total wattage would be all of 0.2 watts. Now, maybe there's something wrong with me here, but 0.2 watts does not seem to be enough power to cause any kind of significant heating in here, really. Like 120 degrees C on that. Now, if it were the case that the current flowing in here is ridiculously high, that would cause a ridiculously high voltage drop here. And you wouldn't have much left on the other side of it. B plus is on this side, and something is left over here after the voltage drop. And what's left over here is what's operating part of this tube. Well, how little can be left here because the tube is operating, the radio's operating. So let's go visit the schematic. I was just peeking at it a few minutes ago, and there's a couple of important observations to be made on the schematic. And then we'll do a little experiment here and try to determine if is it me who's out of calibration? What is out of calibration here? Okay, so we're looking at the schematic. This dotted line represents the extent of the metal tuner box. And this is all the stuff inside. And I've been focused on this resistor here. This is the one that's getting hot. This is the capacitor that I determined was shorted, or at least partially shorted. It's kind of odd too. So I've replaced this, and I put in a 2.2 thousand ohm resistor, 2200 ohm resistor here. And it's gotten terribly hot. Terribly hot. So the interesting thing I didn't really pick up on the last time I looked at the schematic is this information sitting right here. A voltage and a current. So if I were to take out my voltmeter and measure the voltage here at 185 volts, I would be pretty hard pressed to think anything other than what has happened to this resistor in terms of its temperature is that I've put too low a wattage of resistor in there. I'm thinking the resistor that's in there is a half watt-er or maybe a 1 watt-er. 1 watt resistor. If we follow this circuit to find out where's this DC going, you can stay through these coils, avoid those capacitors, come up here, divide between this inductor and the resistor and get to the plate. Is there any other opportunity for current to flow? Well, some kind of short circuits in here, some kind of component failure in here, current could find its way to ground. But again, if it did and excessive current were flowing here, this voltage would drop. Now, is it possible that radio whoop. It's just a timer going off telling me I have to go do something else in my house here. So how could it be that this radio sounds okay, it seems to be working, if this isn't 185 volts or something very close to it? And it gives the current right there, 8 milliamps. So that means it's not even 0.2 watts, it's less than 0.2 watts. Well, I don't know, that's a real mystery. I guess our options are easily here. Measure this current. Measure the voltage. Measuring the current isn't so easy, but measuring the voltage is pretty easy. Measuring the current's not impossible. pull this tube out, see what kind of current or voltage is sitting here. I would think when you pull this tube out, there's no more plate current circuit, no more plate current, no more current in this resistor at all. So we should really see the voltage here identical to the voltage there. Very easy test to make. I think we should do those before I think too much harder about this. Just by the way, the other half of the tube has a similar arrangement. The plate is fed from here. There's their voltage and current measurement. There's the plate resistor. This one's a 10K as opposed to a 2K over there. There's a capacitor to ground. It's the same basic arrangement, if you like. Here. This guy's not getting hot. At least I don't think it is. I don't think this is a special resistor. I don't even know which one this is yet in the on the tuner box, but I don't see anything getting hot other than this one. Defective tube. So the tube I have in here is not actually an ECC85. It's an alternate tube I'm kind of experimenting with. Is this a failure of the experiment? Is there something more going on in the tube I'm using that I don't realize? Some pin connection that's different in some way? You notice over here, well, I guess what they're trying to show is there's a single heater. One heater, two cathodes. Is that what that's supposed to show? I think so. I don't know. Some experimenting and some measurements, and the truth will be known. And just before I do this test, when I did operate the set and this resistor was getting hot, I had the set in FM, I noticed the magic eye was working okay. And in fact, I was watching it when I flipped to FM, and the magic eye brilliance didn't go up or down. So it was a little hard to suggest that there's some unfortunate current flowing in here, because there would be other effects on the radio that are not apparent. Instead, the radio seems to be working. So I'm not going to be too surprised if I read the correct voltage here, which, let me just put it up on my own screen here. It should be 185 volts. And on the other side, I don't know what it's supposed to be over here. Can I quickly figure that out? Just bear with me for one moment. Will I just peek at some other parts of the schematic, and I think the short answer is 224 volts. 224, so 225 on one side, and 225 on this side, and 185 on the other. Okay, let me just get the right schematic up here on my screen to my left. Okay, we're ready to start. We're going to start on with the radio switch to broadcast mode, just AM radio, just to make sure that part's working. Before we go any further, we'll also make a measurement of B plus as found on the magic eye tube. We'll start with that. What do we see over there, Mr. Meter? Settle in around 230. Okay, now we should be seeing nothing over here because the FM's not on. I'm a winner. Okay, now we're going to put on the FM side of things. AM's working okay except crackly. FM. Not particularly good. This side, there's 211, and on this side, 185 exactly. Oh my gosh. Wow. I just need to put a much bigger, higher wattage resistor in here, I think. There is no problem. Of course, the magic eye is going over here. Now, why did...
Download the free app today by searching for the radio Radio Player Canada app on your smartphone. By searching us online, Fresh 93.1.
We've had the pleasure of working with Rachel at My Better Mortgage twice. And after selling our home in Ontario, we knew if there was anyone who could get us into a new home in New Brunswick, it would be her.
Okay, well, radio's working quite well. It still has a bunch of tired capacitors in it, but despite that, it's working quite well. I think I'm just going to have to put the higher wattage resistor in here. I'm going to let this run for a minute, get my thermal device out, and we'll check the temperature once again there. Okay, who's hot, who's not? So right now we're set this top temperature a little bit too low. Raise it up. Only things will turn red that are very hot. Okay. Now I know it's lousy on the camera there. It's interesting in that my eye sees this as bright red, but on the camera it's white. So don't quite know how to explain all that, but in any case, that's the tube we're seeing there. That's the resistor, this little piece down here. Okay, and the resistor temperature is, let's see, a 92, 96 in there. Now, this current that's heating this resistor up is also flowing through this coil. Sometimes it's very tricky to know what you're looking at with this. That's the resistor and the tube. There's no heat in the coil. Oh. It's going to give me a copyright hit for sure. Looking for any other hot stuff. What about that other plate resistor? Why isn't it showing up here as a hot guy? Just this one alone. Well, I can't see that there's a problem here, except for the resistor is too hot. I need a resistor that won't get as hot as that one. That's tricky to do. I do have a larger one I can put in there. I think it's still going to get pretty darn hot. I guess it's just a design issue, and they were well aware of it because they put these terminals here so you could lift the resistor up. And I wonder now if heat from this overheated resistor didn't travel down through the connection and get onto the capacitor underneath, get onto this capacitor, and even cause this reshaping of the end of it, which I'm really starting to stretch the story. This was actually this way anyway. This end's farther away. But I wonder if heat didn't come down and wear out this capacitor, turn it into a resistor. Huh. Okay, well I have no choice but to change that resistor because I just don't think 90 is good. 90 is too hot. Okay, I think we're ready to try once again. Here's a look at the resistor I've put in. Surely, I haven't got anything bigger than this. This is a big one here. Any bigger than this and they're wire wound. And I just don't think that would be appropriate. And there wouldn't fit either. A wire wound resistor is a little fatter. Okay, so what I'm hoping to do here is simply drop this viewer down in front. Something like that. And, whoa, yeah, I dropped the camera on the floor. How's that going to do? That should be alright. Okay, let's see, we're right on FM to start. So I'm going to go right on here. In fact, while it's initially warming up, I'm going to read the I think I'm going to read the voltage just to be doubly sure that it's correct. Okay, my voltmeter lead here. Okay, there we go. Wait a second. No, that's not a short, that's a connection. Okay, watching the meter now. $350. It's supposed to be 185 when all is said and done. Well, that's pretty much 185, isn't it? Right on the money. Okay, now we'll try the viewer here. I'm not sure how this is going to come out, but let's give it a go. See what happens. That's the resistor. And I'm getting the... No, it's not the resistor. I think that was the tube. Resistor is showing no heat at all. What? Come on. Really? Well, it has to do with the settings of the viewer. But yeah, that red thing is the tube itself. Well, there's nothing showing up at all. You can basically look right at that resistor, and then as I drop this down in front, there's just nothing. There's a little tiny bit there now. Here, it's coming. That fuzzy yellow color. That's next to no heat. Maybe that other resistor, I just really under or overestimated its wattage. So it is warming up. A little more mass in this resistor. Might take a little bit of time to get right up. It's what, the 37? That's perfectly fine though. That's the tube. And that's the resistor there. What a difference. So I'm going to let this run for a few minutes. I'm sure it's pretty much at its maximum temperature already. It shouldn't take too long to reach its maximum. But, I think that's going to do the trick. Let's give it a little bit of time though. Thought I'd try some drama here. So you can see the tube glowing away. Color's off in the camera though. It's glowing red. It's not glowing purple or whatever that is. Okay, how hot did you get? I gotta get another copyright hit for that. Leaving the music playing. Here we go. Okay, so it's not red, but again, that's just the settings on this viewer. The actual temperature of it, it's really tricky. How do I know I'm on it? Okay, let me just do it myself here. It could be a little more certain. 56, 57 degrees. 60 degrees, so this would be pretty hot. Not leaving any skin behind, that's good. But I can get away with touching it. Doesn't feel hot at all. And I find the heat sensitive part of my fingers are back here, just behind the nail. Maybe it's because it's thin. Maybe because the skin is thin. You know what? That's not even very hot. I don't even believe it's 50. What a difference. I'm shocked. This is a lesson in itself. Okay, 54 degrees. Very good. Okay, well anyway, we solved all that. That whole thing is finished now. Good. It really started with a defective capacitor for whatever reason and a weird resistor. But now everything's back to normal. We got the right voltages there. Excellent. I think for now I'll leave the can off since I have it off now and carry on with... Let me turn the power off here before I make a mistake there. carry on with starting to get rid of some of these very old capacitors. You can see down in here. It looks like there's quite a few of them actually. Yeah. Now the radio's working, so how many of these do I really need to change? Maybe we should start with take a closer look at them and make a judgment. These ones don't look as bad as in other radios, and I'm not into doing unnecessary work. I'm really not into that. The rear radio's off, so we should be able to just switch cameras here and carry on safely. Okay, so we can start with these two guys here. Well, a little too much dust in there to really judge the situation with them, but I'm looking at the ends of these capacitors. Like this larger one, we can see what would look like some junk coming out from inside it. The larger one I'm talking about, because there's a few in the view here. I'm talking about this one here, the one I'm pointing at right there. You see, so it looks like something coming out of the edges of it. The other end, can I get around there? Very hot tube here. It's still hot. Well, it looks kind of funny. And the one that's on the right side of the screen looks a little funny on the end. Is that right? It looks like the wire coming out of it. This is again on the right side of the screen. Looks greenish. Yeah, they all look a little greenish. That's nothing. Got my camera wire all tangled up in the radio now. So I'm trying to assess whether it's worth changing these out, because once again the radio is operating. Now this big one here, this is the one that's kind of in the middle of the screen, the biggest capacitor there, the yellowy one. The end cap, if I can call it that, is separated a little bit again from the barrel of the capacitor. And the one beside it, the darkened one, that one looks really bad. Doesn't mean it's bad, but it looks bad. Interestingly enough, if you just look, you'll see a little sticker there that says fuse, heating, wire gauge number. And you see just above it, you can see a wire, just a thin wire, just casting between two terminals. That's a fuse, and I believe it's related to the heaters. Why it says heating, I'm not sure. Shouldn't it say heater? And they give you the wire gauge and that to put in there if that burns out. Very odd. I've seen that in a number of these radios, Nordmende radios. So what about that other capacitor? I think, well, I can't tell for sure. It may be electrolytic. In that case, in that condition, it should go for sure. Now, around the back side of this hot tube here, which maybe it's not so hot anymore. So you see that brown, shiny, glossy looking capacitor there. Those ones generally are not very reliable either. It's a different style, but I find these to be unreliable. And what's that junk down beside it there? Okay, so I've decided to take out a big, physically big one. This is a big one. There's a bigger one back here, but I'm going to start with this one. Definitely it. Did a little X-ray thing there. You can see, shine a bright light on the board. You can see through. You can see the trace and all that stuff. You just did not pull hard enough. There it goes. I did not pull hard enough. Okay, so what's happening here? So what has happened is I pulled up one leg of the capacitor I'm after. Here. Now I can pull on the whole capacitor. pulling on the other connection. And the other connection has got to be this. Got to be that there. Mainly because I say so. Yeah. I find if I put my fingers on either side of the board and, you know, touching things and whatnot, I can tell if my fingers aren't lining up or not. Right in here. Yeah, that's it. It is bent over a little bit. There we go. We got them out. Let's take a good look at this. This is kind of representative now of the whole series of similar capacitors that are in here. Now I have my anti-camera bobbing device, which is basically a chip of wood here. Let me install the anti-bobbing device here. Yeah, I don't think it's going to stop the bobbing too much. Okay. 0.1, 220 volts, 500 volts DC, I guess, 220 volts AC, I guess that's what they're trying to say. Yeah, 500 volts of the straight line there. So this actually doesn't look to be in that bad a shape. In fact, it looks to be in very good shape, this particular one. Looks a little open right on the end here. Here, let's get the other camera. Because we get a better look at it. Well, yeah, so it looks like the seal is lost here. Now, some of that funny business would be for me pulling this out. That's kind of what, well, you can see what fresh funny business looks like. Generally not too bad looking. Next step is going to be on my tester here. Okay, since it's possible you have not watched any of my videos, I'd like to test pretty much everything I take out of a radio to find out what the truth really is. Let me turn this on. Get her warmed up. So this is a vintage capacitor tester. I mean, it's a vintage device itself. The Heathkit stuff is pretty good. You can see it has an eye here. You can see the eye is open. So what I'm going to do is I'm going to apply a voltage here starting at 50 volts DC on this capacitor. If the capacitor is leaky, the eye will not look like that, it will be closed. Initially there's going to be a charge current. The device can't tell the difference between a leak current leaking through the capacitor and a charge just going in. So initially it's going to close, and it's going to open, and when it opens, if it looks like that, then this capacitor is still okay. Here we go. 50 volts. Some time because it takes time to charge up, so it's almost all the way open but not quite. If I let go, you'll see that it gets bigger. I'll put it at 150 volts. I bet you it doesn't open at all here. Yeah, it's not going to open. So this is a typically not so good capacitor. Not so bad. Not so bad it's ruining the radio. Not so good that you should leave it in there. It's only going to go downhill. It's going to leak more and more. Depends on the particular job of this capacitor. Why don't we take a look, see if we can find this on the schematic, and just see what we're playing around with here. Okay, so this is the schematic, and at the bottom of it, you know, a lot of these German schematics, I guess the Nordmende ones, but anyway, they have this interesting table here. The way this works is, I don't really see this in North American schematics, but over here they put capacitor, resistor, and inductor, and then they have a numbering system which just carries on 1 to 65 off the page, and then 66 on to what would it be, 110, and then it starts here at 111. It just carries on. So all, and then you see there's a capacitor called number 2 right here. It's 100 picofarads, but there's also an inductor called number 2. And the thing about this diagram is these parts can be found directly above. That's the whole idea of this diagram. So it's a bit of a map of what the parts are, where they are, things like that. So we look on here and try to find a point 1, and it's over in this area here. Actually, it's probably on the other schematic. But I've already done this quickly because it takes some time. Here's 181. That's a 0.1 microfarad, 250 volt. Well, I've got a 500 volt capacitor I took out. So is this it, 181, or could it be the other 0.1 I found here, which says 500? So we can get a number here now. 147. The number 1 and the number 7 are so similar the way they've written them here. It's not so good. Keep that in mind. 147 rather. So we need to find 147 up here somewhere. There's a 0.1, 147. Is it hidden away somewhere? There it is. 147.22. Huh? What did I do wrong? I done something dumb. It's 141. 141, Jim. First I say, look, you can mix up the 1 and the 7, and then I go ahead and do it. 141. 142, resistor. 145, 143, 142, 141. There it is. Boy, what does it say there? 141. It goes to ground. This capacitor I took out does go to ground. So if this is the right capacitor, which I think it is, we have the B plus coming in here, high voltage B plus here. We have a voltage divider to the plate. This looks like a tone control here. It's just a filtering system, filtering out something. Filtering out any RF or something like that. Because at this point, all that should be is the audio signals. All that should exist here. So it's probably trying to get rid of any RF that's still persistent. And make it not the most important capacitor if that's the case. And it's right on the B plus. The B plus can afford to leak a fair bit of current before there's trouble, big trouble. So a fair bit being, microamps, tiny amounts of current through these capacitors. So probably sitting in this position, leaking a little bit, have no bearing on anything. If the leak got really bad, you'd start getting extra voltage dropping here, but that would be quite a bit because the current flow through this tube, this one's going to be something like 10 milliamps. So probably this would have no effect on the operation of the radio at this point, but in the long run. Okay, not the most exciting finding, but there it is. Good. How good is it? Let's take a close look. Expose my semi-professional quality of workmanship here. Well, that looks great. That's this one here. And then its brother over there. Looks good. Okay. Very good. Just a whole bunch more to do. Okay, next capacitor I've taken out, you can see it right here. I decided to take out this, what looks like an electrolytic capacitor. I'm pretty sure it is. All darkened down. Let's look at it through the other camera here. We'll get a bit of a closer look. (100/15). So my guess is that's 100 microfarads, 15 volts. That's my guess on that. So if we look at the ends, of course that's the sort of the can end. That's okay. But this top one will have a sealed end, and how good does that seal look? Not particularly good. Looks like something's been going on right around where the lead comes out. Does it mean it's no good? No. Okay, let's give it a test or two here. So I think I want to test it with... Let's try this tester first. Electrolytic capacitors are leaky from day one. I don't know about modern capacitors, but certainly the older ones, leaky from the start. You know, a tiny leak, but used in applications where a tiny leak of current doesn't really matter. So this is probably a bypass capacitor. It's right near the output tube, so it could have something to do with that. Let me just... Really? No part or damaged part. Something about this doesn't make sense to that tester. Let's try it again. Okay, that's interesting in itself. Put this on the capacitor checker here. Now this is an electrolytic capacitor, so there's a setting I have to change over here, which I often forget to change back afterwards, so don't let me do that. This changes the calibration of the eye in such a way that it, because these are always a little bit leaky, it's too sensitive otherwise, so now I have to do this in the proper polarity. So we'll go plus here, minus there. And this was a 15 volt capacitor. Well, you know what? I've only got 50 volts. Boy, oh boy, if I put 50 volts on a 15 volt tired old darkened capacitor, what's it going to do? It might go bang right on the spot, but it won't go bang in this device. It'll just, there'd be no excitement if this fails. Okay, watching the eye. Popped right open. Now the other tester said there was no or an unknown or a damaged part. It's possible that this is showing the way it's showing up because the leads have disconnected from the inside of the capacitor. That it's actually an open circuited capacitor. Very good thing to find. Let's try measuring its capacitance on here. This is supposed to be 100, so I'm on the 20 to 1000 scale. So that's 1000 up here. 20 is just about where it's 20 is here. Why do I care about a 20? I don't care about 20, I care about 100. 100 is here. So now we watch the eye for it to open at some point. It's not opening. I think we found a real sick capacitor here. I think this guy's if the lead is disconnected, it may test as a tiny capacitor. On the other hand, it may just be a dead dog. Yeah. I think this guy was bad. I'm going to find him on the schematic so we have a better notion of what we're working with here. So the one I think we're really after is this one, 148, right near the output tube. So we're looking for there's 146. 6. That's a resistor. So this would be almost like right here. There it is. As soon as I start thinking if it's a bypass, it's going to be here. So this is a fairly important capacitor in terms of getting good sound out and loud sound out. Now, this radio seems to be working pretty good, even with this capacitor. Apparently, not there at all. This capacitor appears to have no capacitance. Okay, I have the replacement here. This is actually good for 25 volts, so it's a little bit of a stronger one, a little difference in size. Okay, and we want to make sure we put the polarity, put it in proper with its matching polarity. So this resistor, this capacitor was like that, negative at that end. This guy's got his negative bar, negative at that end. Roughly spread, okay. Now, there's a whole pile of holes here. Make sure I get it in the right one. That would be the right one. Okay, on that end. Now on the other end. Yep, that's the right hole. Good. Okay, look on the back. Good. Ready for soldering. Okay, let's see if this radio's still working, or if I've done something terrible to it. So I'm gonna volume down, flip on the broadcast. I got my eye on the. Well, you can too. The eye on the lights. There we go. Lights are behaving normal. That's good. Okay, we'll give it the full Monty of power, 118.2 volts. The light has come on. Here comes the scratchy AM sound. It's not very reassuring, that sound. Has nothing to do with the tuning. Okay, let's go shortwave 1 just for a moment here. Very same thing. Okay, now we'll go FM. Here we go. This is what's really quite important anyway. Nice hiss. So it could be just very directional antenna.
I had friends that went, and they Mennonite friends, which just blew my mind. And they explained
Something
that
strange happened.
Did
something strange happen there?
That was miracles, and that the pastor had celebrated something called
Getting weaker and weaker.
Ask questions.
No, that's not weak.
You're hurt to the head.
So I think this is a religious FM station here.
He's not afraid of your doubt.
Very, very directional antenna, FM antenna. Okay. We still have the can off, the tuner box. I think there's a good chance that's kind of detuned this a little bit, and probably it's in need of some adjustment anyway. The other Nordmende radios I recently did had a really bad FM alignment up there, so but I think everything's okay. We're good. How hot is this resistor over here? It says touching it. You can tell how loud I yell when I... Not hot at all. Of course, we only had it on FM for a short while there, but not hot at all. Okay. Still is a mystery to me why that other resistor got as hot as it did. Great. Okay, so a couple capacitors done. Lots more to do. That'll be the plan tomorrow. Thanks a lot for watching.